right, so welcome back, everyone. So today we are going to be covering decision-making statements. So Steve went into these today, so we'll do a quick review of how they work, the flow in which they are executed, a bit of an analogy of why we use them. And then once we have a solid background on what they are and what the syntax is, we will do 3 separate examples with those if we can get to it. We'll do a number guessing game in which the user needs to guess a mystery number, and we'll take their input and determine, is their number equal to the mystery number? Is it greater than? Is it less than? Kind of like a game like that. Then we will update our quadratic roots calculator so that if we have no real solutions or if we have only one solution, it can actually determine that. So that sounds a lot like conditions. We're having a non-linear flow of code. And finally, we'll add some if statements to our calculator and improve that. All right, so starting off, and always interrupt me if you have any questions or put them in chat. I will be looking for those. All right, so decisions are very important in everyday life. We make them all the time, and they are just as important in programming. Decision-making statements are very, very, very important in your codes. They allow our codes to do dynamic processing of data where it can actually make decisions on its own. So let's take a little analogy here. We're going to go to a restaurant and we're deciding, I feel like eating pizza for lunch. I haven't actually personally eaten lunch, so I feel like some pizza right now. We're saying we want some pizza, but if the restaurant doesn't have pizza, we're going to order soup instead. So this is a decision. We have 2 things that could outcome from this decision. We're going to either get pizza, or if they don't have pizza, we're going to order soup. This can be expressed as if the restaurant has pizza, we're going to order pizza. And otherwise, or else, this is the thing for otherwise. So if all else before is false, we are going to order soup. So we use very similar decision-making statements in programming, in which we have an expression, which can be either true or false. The restaurant does or doesn't have pizza. And then based on that, we'll either order pizza or we'll order soup. So let's take a look at the flow of this. So this is the flow chart. You'll see a lot of these throughout your programming education because they are very useful for codes, especially when we start breaking up into multiple branches. So the first part of our little lunch journey here is we're going to a restaurant. We're going to do that no matter what. Then we reach a decision-making statement. We need to determine if they have pizza. If they do have pizza, we're going this way. We're going to order the pizza. If this is true, if they do have pizza, that's a true statement, we're going to order it. And then if it's false, we're going to do something else. This is another way of saying otherwise. A lot of times when I think of the else command, when I'm writing my code, I think otherwise. If everything above did not work out for me, otherwise, I'm going to settle and order soup. So this is similar logic that you'll see in your program, just applied to an everyday sense. All right, so notice that the decisions that we made were based on Boolean values. This is either true or false. They either did have pizza or they didn't. And we use that information to decide, are we ordering it or are we not? So in C++, we can't really write the stuff out like words like this. However, we can translate it into something similar. This is just to kind of give you guys an idea. Instead of saying if they have pizza, we need to use a combination of logical operators and Boolean operators. And here are a few of those that you guys should get familiar with. So these are the 6 that are used for comparisons. They're very similar to comparison operators in math. We have the equals to, and C++, this is very, very important. Equals to, the double equals, and the equal sign are not the same. So who can remind me, what does the regular equal sign mean in C++?
Something about an assignment?
Yeah, you are absolutely correct. The equal sign in C++, we call it the assignment operator. We shouldn't even call it the equal symbol. What it does is it takes a value on the left and we assign it another on the right. So basically what happens in this expression is whatever is over here sitting in this variable or box or whatever is here gets assigned to whatever is here. That doesn't necessarily mean that these two things are equivalent. So that is a very important distinction. This is an assignment statement. It is not testing. Is value equal to another value? If we want to test if value is equal to another value for a condition, we would substitute this for the completely different double equals operator. Now, what does this statement mean? If anyone knows. And if you don't, no worries, this is all completely new stuff. So what this statement means is it's testing. Is whatever the value, what is inside of value, equal to another value? And it's either going to result in true or it's going to result in false. One of the two. It's not assigning, it's just seeing, is it true or is it false? And that's what you'll result in. All right, so that's the equals to. Not equals to is written as an exclamation point, then equals. Greater than or less than are the exact same as they are in math, so that is very nice. And less than or equal to, in math, we write it like this, but there's no this symbol on your keyboard. So to make it a little bit more convenient, so you're not like doing shortcuts on your keyboard, we write it as the symbol, the less than or equal to. It's written as it's said. So when you're writing this out, kind of think in your head, less than or equal to. So less than comes first, then equals to. This is not an operator in C++. So symbol has to come first. And then similarly, greater than or equal to. All right, so I have a series of these Boolean expressions here. So we're gonna just do a few of these, probably not all of them because they get a little redundant, but this first one, what does this result in? And you guys can type it in chat. All right, we have one answer for F, which I'm assuming means false, and that would be absolutely correct. This is a false statement. 8 is not greater than 9. It's resulting in a true or false value. All right, true. Correct. How about, let's take a look at this one. What do we think? This one is actually false. So this is a strict inequality. So if we had a number line, which is a really good way to look at some of these, remember on your number lines, we have inequalities in which we have a solid dot, which means that we include it. And then we have inequalities in which we do not include it. So this is a non-inclusive inequality. So 29, it's saying it's greater than 29. So it's not including the 29 part. So this is a strict inequality. However, if we said greater than or equal to, then yes, this would be true. So distinction between those two, this guy is false. What about this one? This is a little tricky one. That is correct. Good job. True is the correct answer here. This compares if this thing and this thing are not the same. So if I actually had a 7 here, is 7 not 7? So that would be false. So that's a little bit of a tricky one. You'll get used to it. So the correct answer for what I had here was true. And it's important to note that we usually don't actually use just plain integer values like this. A lot of times we will use variables. So if num1 is 6 and num2 is 5, what is the result of that one right here? All right, let's take a look at this. So num1 is 6 and num2 is 5. So we can rewrite this if the variables are a little confusing at this point. Is 6 less than or equal to, actually I'll write it the C++ way because we're in C++, 5. So this results in false. All right, very good, good work. I think that's all that I'll do on this slide. It seems like you are getting those very well. Does anyone have any questions on these relational operators here? And while you are thinking of those, if you did have any, I'm going to prove to you that everything I just told you is correct. So here I have a program which is going over the exact same equalities and inequalities that we just discussed. And I am using them as the condition for my if statement. So remember how this works. What happens here is your program starts at main, right? That's exactly where your program always starts. So we're going to start here. Then we're going to declare two variables. We're not assigning them any values. They're just here. Then we see this if statement. And what happens now is your compiler is going to evaluate, is 8 greater than 9? And it's going to look at this and it's going to say this is false. That results in false. So now the if statement does not execute if this thing in the parentheses is false. That means that we do not execute anything between these two curly braces. So we're going to jump from here to here. We're not going to look at anything in between. We could have as many lines. Let's just all pretend that this is good C++ code. As many lines as we want in here. And if this thing right here is false, we are not going to look at any of it. We're going to just go to the next curly brace. So this one connects with this, and then we just continue the code as normal. So we'll get into a little bit more about the flow later. I just want to prove to you that all of these things were working. So we say, if the condition that I've put in these parentheses is true, I'll print out that it is true. So proving that to you, there we go. And 2 is greater than or equal to 2. This is a true statement. 8 is equal to 8. That is true. 12 is less than or equal to 22. 0 is greater than or equal to 0. And 7 is not equal to 2. The rest are all false. Oh, I didn't assign these guys with values. That was bad. Steve always talks about this. Always assign your variables values. All right. There we go. Any questions on these logical operators before we get into, actually it's a relational, before we get into logical operators? All right, and feel free to interrupt me at any time. So now we are getting into logical operators. So multiple of those expressions that we just saw can actually be joined together. So we're going to go back to our pizza example. So what if we say we want to get pizza if and only if they have pizza and it is pepperoni? Otherwise, we're going to settle for soup. So now our first condition of if we're getting pizza or not has two parts to it. And both of these have to be true, right? They have to have pizza and they have to have pepperoni for us to order pizza. And then if those are either of those are false, we're going to order soup. So that is very similar to how this works in programming. So we have 3 of these logical operators in C++, and they function very similarly to how they do in English, which is nice. We have and, we have or, and we have not. So let's take a look at a few of these. Here is a nice handy little chart for you guys of what these operators do. So the and operator, what is on both sides of it? Both of these individual expressions have to be true for the full expression to be true. And then on the or operator, only one has to be true. We could have one false and one true. It's or. It can be either this or this, and then we'll still do it. So let's go back to our pizza example one more time. We could say, instead of what I have here, we'll say if they have pizza and the pizza is pepperoni, or if they have pizza and it's sausage, then we order pizza. So we're adding in multiple descriptions to our condition here. So or only one has to be true, or both can be true. And then we have not, which takes the opposite of whatever is happening. So I'm going to help you guys out with the first one of these to show you how to look at one of these expressions if you see it on an exam or something. And then you guys are going to do the rest of them. So we're going to follow the order of operations. These actually don't have to be in parentheses. It will automatically evaluate each side of the logical operator first, but just to make it clear, I can put parentheses if I want to. So the first thing we're going to do is we're going to look, is 6 greater than 8? Well, this right here is false. And then we say, or 3 is less than 2. Well, 3 is greater than 2, so this is also false. And now I can look at my handy little chart up here, and I see I'm using an or operator. So I'm going to look over here, and I have two false values. So the resulting value of this equation is false, which means that if I had an if statement here, and this was my condition, whatever is in that block will not execute. All right, so let's take a look at this next one. Who wants to help me out with this?
Shouldn't that exclamation mark be inside? Oh, wait.
So the exclamation mark is another operator. So we have the not equal symbol, which you're probably thinking of, that looks like this. This is if this thing is not equal to this thing, then we have a true statement. This, on the other hand, is another logical operator. This is like and or. So what this effectively does is whatever it's next to right here becomes the opposite of its value. So let's take a look at this one. We're going to go in the internal parentheses first. So we're going to evaluate, does 2 equal 2? And the answer to this question is yes, 2 and 2 are the same number. So this right here is true. And then we have a not symbol on the outside. So what the not does, if we take a look at our chart over here, is if we say not, and then some value A, we're going to get the opposite of that. So false becomes true and true becomes false. So this would result in false. We don't see the not operator very commonly. You'll probably won't see it a lot at all, actually. But it's worth noting that it exists just so you guys get a sense of all the different operators that you can use if you ever come into a situation where you need it. All right. Let's take a look at this one right here. I'll let you guys type in chat. You guys can also, you all know that you can private message me if you don't want to type it publicly to everyone else. And what do you think about this? So we're going to pretend we have an if statement right here. And here's your condition. Here's your parentheses. And we have a bunch of lines of code. And we have another not parenthesis, brace there. Is the code in here going to execute? Yes, that would be correct. So let's take a look at how we came across this answer in case anyone is confused. So what we're going to do is we're going to evaluate each side of the relational, the logical expression first. I actually don't need to use parentheses, but I personally like them so I can really see the order of what's happening. But we're going to evaluate this side, and then we're going to evaluate the other side. So 5 equals 5. This is a true statement. And then we say, and, that is a terrible ampersand, but hopefully you guys get the idea. True. And then we take a look at our chart. True and true is true. So yay, that's exciting. We are going to run the code in the if statement. Alrighty. I'll give you guys a random value for X and Y. X I'll say is 4 and Y is going to be 7. All right, let's take a look. So when you have variables, if you're on your test and it helps you out, tests are not for a while, so I don't want to stress anyone out because I keep saying on your test, on your test. But I'm just giving you guys tips in advance. So you will have a scratch piece of paper. So if it helps you, you can rewrite your expression without the variables. So we say that X has the value of 4. So we'll put that in here, which is greater than 8. We need to determine this. And we have our Y, which is 7. Is this equal to, I'm running out of room here, 7. So let's go in order here. So I'm going to say, is 4 greater than 8? This is false. And then, and is 7 equal to 7? This is true. But remember, this is a little different than our or statement. Our or statement says that we can have a false and a true, and we're still going to run whatever's in our subsequent block. And is exclusive. We have to have both of them be true. So a false and a true is a false. Both things have to be true for this to be true. So we'll go ahead and put this one as false. And both you guys got it. So very nice job. All right, last one of these. This one's probably the trickiest that you've seen yet, potentially. Let me know what you think, and we'll go through that one again as well. All right, let's take a look. So the first expression we are going to evaluate is 5 greater than 9. And this is false. So very nice job. So false. Trying to get fancy with colors here. I should not be doing this. All right. And then we have an or. And now we're going to evaluate the second expression. So pretty cool. You can add in your arithmetic operators that we learned last week into these expressions. So this can actually be really handy later on in your programs. You'll see that this is very, very useful. So we can do arithmetic inside of this expression. So first, we're going to see what is 8 minus 7? Well, this is 1. And then we're going to evaluate, is 1 equal to 2? And we're going to go down to the next line, false. And then we have the or symbol. And then finally, 1 is not equal to 2. So this is another false. And we have an or in between them. So let's go ahead and take a look. 2 falses with an or make a false. So good job, you got it. And to prove to you everything I have said here is true, I have another program over here. All of these are going to be available on Canvas as usual. So let me run this. So this is just another series of if statements in which, I forget what I called these numbers. I want to say y was 7 and x, I want to say it was 5. Let's hope it was that. All right, so this is just a series of if statements. So what's going to happen is we create our variables, then we're going to look at this if statement. We're going to evaluate it just like we just did. We just evaluated this expression. And let's see, what did we determine it to be? We determined it to be false. And what this means is, since this is false, we're going to look at this brace, what it matches with, which is this one, and we're going to jump from here to here. And then we'll go ahead and execute the rest of the code. And if we had one that was true, did I put a true one in here? I want to say this one was true. This one's true, right? This one was true. So this whole thing resulted in true, which means that we are going to go into this if statement and execute however many lines of code happen to be in here. And then when we reach the bottom right here, just a comment to signify that this is the bottom. Once we reach the last curly brace at our if statement, so remember we go from here to here, this constitutes our if statement. Then we just return to just doing regular code stuff and go in sequential order, or if we have if statements, we'll go and deal with those as well. All right, so running this code on using it for is to show you guys that these statements are all working. This one executed as true. The rest of these was false, which is exactly what we found here. All right. Any questions on those? They're called Boolean expressions. They're what determine if your branch is going to run or not. All right, please, please, please interrupt me if anything is confusing. I want to clarify any questions that you have. All right, so we have seen if statements. We're going to look at a few more. In C++, we have if, we have else if, and we have else, and we can use these to make many, 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 many decisions. So if statements, these are the most straightforward of them all. So in a series of decision-making statements, which we'll talk about what that is later, an if statement is always first. If you're going to have like an else if and an else, an if statement always has to be the first one that you do. It's always if something, and then we can do all this other stuff. So if statements are the first ones, and they're the first ones to be addressed. So just as we saw, if whatever is in the parentheses of the if statement is true, then all the statements enclosed in that if are going to execute. And if it's false, we jump to the ending curly brace. So here's your example of an if statement. So there's the various parts of it. We have the word if. Then you have parentheses. And then in the parentheses are your Boolean expression. And remember, that expression has to be something that can result in either true or false. So the expression that goes in here has to be something that results in a true or a false value. No, like maybe. Maybe doesn't exist. It's true or false. All right. So then we have brackets, which enclose everything that's going to happen if your statement is true. So we could put as many statements in here as we wanted. And then we just keep putting statements. And as long as the bracket ends the if statement, we can put as many as we want. So those are your statements. They go in between the braces. We have a brace in the beginning and a brace at the end. So if the condition were false, we go from here to here. And if the condition were true, we would execute the statement inside. So let's take a look at this program. Very simple, but I think it's a good thing to see what happens with these if statements in a simplistic way. All right, so I'm going to compile if.cpp. Oh God. Oh no, what did I do? I swear this was working 10 minutes ago. All right, apparently this is turning into a debugging session. Oh, I have the wrong operators here. All right, my bad. Let's take a look at this program actually working. Very sorry about that. Okay, so we are going to enter a value for num, and this could be any value that we want. So let's start with 5. All right, your number is 5. So let's see what actually happened here. The flow of the code. First thing we do, we create an int variable named num. Then this is just a cout statement, no different than we've seen before. Cout just prints to the console. Is an input prompt, so we're getting our input. Now num has whatever value that we gave it over here. So num, in this example, is 5. So now we're going to evaluate this if condition. So we're going to say if num, which has the value 5, is less than 0, then if that's true, we're going to make num 10. And otherwise, we're going to jump. So it evaluated this condition and it said, is 5 less than 0? No, that's false. So what happened was we went from this curly brace to this curly brace, and then we just executed the cout statement and ended the program. Let's see what happens when we add another value. So instead, let's do -6. Okay, so what happens here is num -6, and then we say if -6 is less than 0, this resulted in true. And then we did num is reassigned with 10. So this is your assignment statement. Very different than your equals. So num is 10 at this line, no longer 6. Then we output your number now is 10. Any questions on that? Are the basic if statements making sense a little bit? All right, let me know if they are not. Now, it is time to look at the part that gets a little bit more confusing. This is the additional part, so we can add to our if statement. It is else, if, and else. Did I have slides on this? Let's see. I do. Okay, fantastic. Okay, so else if statements follow the if. So we have an if condition first, or if always is the first condition. We check if something is true. Then if we choose to, we don't have to, but if we choose to, we can check subsequent conditions. And one of those subsequent conditions we can add on is an else if. If the previous if is true, the else will not execute. This is very, very, very important. And this is where people get confused a lot. So I'll show you what I mean in a program. I think that's the best way to show this. And then else is something that we saw in our pizza example. It's the otherwise. Whenever you see else, just think otherwise. If everything else that was happening in the sequence of decision-making statements was false, we're going to do this catch-all else statement, and whatever's in our else brackets will execute. And an else has no conditions. No conditions are required for the else. It's otherwise. All right. So I have 2 examples here of some code that I wrote. If num has the value 9 in my program, and I'm going to name these lines A, B, and C. Which of these lines, it could be multiple, or maybe not, which one's going to execute? All right, so we have one answer for all of them. So let's take a look at what's happening here. And this is just some programming language that you're going to have to get used to. So the first thing we say is if. So we know that this is going to be a decision. Then we say num if it's 9. So if num is 9, this is going to be true. And num is in fact 9. So this is true. That's a true statement right there. So A is definitely getting executed. All right. So A is a correct answer. Now let's take a look at the rest of these. So this is where things get confusing a little bit. Else if is not a separate decision from the if. Basically what's happening here is it's a version of otherwise almost. Let me see, how I can put this. Okay, so we're going back to our pizza restaurant. We say, if the restaurant has pizza, I want to order pizza. And then otherwise, if the restaurant has a sandwich, then we're going to order a sandwich. And then otherwise, we're going to just go home. So we have if there's pizza, we're going to order that. And then otherwise, if or else there's a sandwich. Oh my God, my writing. We're going to order. And then else, there's no condition here. We're going to just go home. So what's happening here is pizza is my top choice. I want to get pizza. So if I have pizza, I'm going to order that for lunch. None of these other conditions are going to happen. I'm not going to order pizza and the sandwich. I'm going to just order the pizza. So I order the pizza and nothing else, and that's it for that. If they did not have pizza, what am I going to do now? Well, now I'm going to see, do they have a sandwich? If they had the sandwich, then I'm going to order the sandwich, and then that's all I'm having for lunch. And if they had none of that, then what we're doing is we're going home. So it's important to note that else if happens if the previous conditions were false. So remember, when they didn't have pizza, we got the sandwich. However, when they did have pizza, we just got the pizza and that was it. So it's the same thing that's happening here. Hopefully my convoluted example makes a little bit of sense. So what's happening here is this one was true. And then we just go from here. We enter the if, we execute that statement, then we end up here, and we get out of this decision-making loop. Your if is your first choice. The if is the first choice. If the if is true, that's fantastic. We do that, and then we're done. We do that, and we're done. So this line never gets executed. If our number was 10, now what's going to happen, we're going to say, is 10 equal to 9? No. Then we're going to go to our otherwise if condition. If 10 is greater than or equal to 9, we're going to execute this. Yay. Yay, we're going to do this one. That's the line that's getting printed. And then we go from here out. The else doesn't happen. Remember, this is the otherwise. And finally, one last example. If num was 7, num is not 9, num is not less than, num is not greater than or equal to 9, so we do the otherwise. Everything else up here was false, so otherwise or else is the one that executes, and we run that line. Questions on that? I know it's a little bit confusing. You'll get used to it. Any questions here? And I'm going to prove this to you again. Here's the exact same code I was just talking about. If and else.cpp. Same exact code. And let's run it with the examples that I gave you. The first one I told you was 9. And we predicted that only this first statement's going to execute. Let's see. Your number is 9. So what the code did is it saw that our number is 9. It looked at our first condition in our decision-making list thing. It saw it's true. It said, fantastic, our number is 9. Then when it got to this brace, it just gets out of this. It just goes down here and executes whatever code is remaining. Let's try 10. Your number is greater than or equal to 9. So this one executed, and once it finished, it just exited the decision-making clause thing. And one last time, I said 7. Your number is less than or equal to 9. So this was false, this was false. The catch-all condition happened. All right. Now let's look at a little variation on this. My number is 9 again. What's going to happen? A, B, and C. Yes, you are absolutely correct. These are completely independent statements. When we use else if and else, they're kind of dependent on the main if or any subsequent statements that follow. They're all dependent on each other. So we say, like, if this decision happens, then we do this, then we do this. It's all dependent. These are all independent if statements. They're all on their own. So we're going to evaluate, is the number equal to 9? We execute, your number is 9. Is num greater than or equal to 9? Your number is greater than or equal to 9. And finally, if our number is less than or equal to 9, your number is less than or equal to 9. Every single one of these statements should execute because they're completely independent from each other. And let's go ahead and prove this. So G++, if, else, 2, and we get this code up here. So the exact same code I had on the slides. And we're going to run it with our number being 9. And as predicted, very nice job. All 3 lines got executed. So the thing to note is when you have if statements that are independent from each other, it evaluates the condition as you would expect. It's when you have these else if and else conditions that those conditions are inherently dependent on what happened above, if it was true or false. All right. Any questions on this? Because if not, we're actually going to code something. All right. Please, please, please let me know if anything is not making sense. So
No.
go ahead.
So quick question. So your examples listed as an if, else if.
Mm-hmm.
What if you have an if statement with an else if, but no else at the very end?
So let's actually try that. Let's see.
And so you have an if, else if, and then another if statement and more code.
We're going to remove this else part, right? Is that the idea?
Yes.
Yes. Okay. So let's try it. You do not have to have an else. That is a very good point to bring up. So thank you for that. And if and else .cpp. All right, look, it's still compiled. It's not complaining that we don't have an else. So what's going to happen here is the first thing that we're going to evaluate is our number equal to 9? So let's try our number 9 again. But let's predict what's going to happen first before I click enter. It's going to say if our number is 9, it's going to output your number is 9. And this functions exactly the same way as our previous one did. Because our if executed, it's our top choice. It's what we want for lunch. This is what we want to happen. So top choice. And it did happen. So we're happy. Yay. It happened. So that means that we are not going to execute the else if. And remember, when one of these is true, we just exit the entire decision-making clause. So now let's just pretend I'm going to actually prove this to you a little bit better by having a cout statement here. Okay. So no errors. We're going to enter a number. That number is going to be 9. And we reach the end of the program. So we exited the decision-making clause, and then we're going to continue the program as normal for however many lines are here. And we're going to just run them in sequential order if they say so, or if we have more ifs and elses down there, we'll deal with that when we get there. Let's try if our number is 10. Let's do all the same examples. All right, it says your number is greater than or equal to 9. So the first thing it did is it checked, are we 9? No. So that means that we're going to do our second choice. We're going to say, is our number greater than or equal to 9? It was, so yay. Our number was greater than or equal to 9. So we're going to execute this statement. And then that's the end of our decision-making block because we executed it. Then we just go down and continue with the rest of the code. All right, that one hopefully wasn't that too unexpected, but let's try the other case that I think people might be wondering about. What happens when we don't run into any of these? Absolutely nothing. So we went through, we checked, is our number equal to 9? No. Is our number greater than or equal to 9? No. Oh no, we didn't run into any of those if statements. So none of them were true, which means that we are going to just continue on with our program. Nothing's going to happen with those. It just checks all conditions. We can have as many of these as we want. We can put like several else ifs if we wanted to, and else like if, else if, else if, else if, else if, else if, as many as we'd like. And if all of them are false, it's going to check all of them, right? It's going to check every single one. But if all of them are false, we're going to just continue on with the rest of our program. Did that answer that?
Yeah, that was great. Thank you.
All right, awesome, of course. All right, so we have 3 options of what we can do with the rest of the day. Whatever we don't choose to do today, I will have for Thursday, but just whatever sounds most interesting to you guys. We have 3 options. We could do A, the mystery number program. So I'll show you how that looks like running. I'll get this out of the way. Wait, nope, I didn't want to do that. Oh, I just messed up my entire slides. Okay, 2++ and all right, so here's the mystery number program. Basically, it says enter a number between 0 and 100. The user enters a number. We tell them they guess too low. They run the program again. They're gonna guess a higher number. You guess too low. We're gonna run the program again. 98, you guess too high. And it's just a little game until you eventually get the correct number. And then we tell them we guessed the mystery number. So that is program A that we can do. Program B is we're going to update our quadratic equation program that we did last week. So that was this one in which we calculated the roots to a quadratic, meaning where your graph intercepts the x-axis. So here and here, we figured out what are those points based on a quadratic using our equations here, but we noticed that we were getting some weird output towards the end. When we didn't have any roots, we were getting not a number and not a number. And if we only had one x-intercept, we were getting the same thing twice. So I told you guys we would later look at how we can fix that using decision-making statements, and we would take a look at that, fixing that up. Or finally, we could fix our calculator program in which now the user could actually enter a simple math expression like this, and it would calculate the results. So of those 3 options, A being mystery number or guessing game, B is going to be quadratic, and C is going to be calculator. Calculator, which one would you guys like to do? And you can answer in chat because I think we have time for one of these. All right, I have a message for C. Unless anyone has any other ideas what they'd like to do, let's take a look at what C looks like. So first thing we're going to do is actually show you what C looks like. G++, and I have the answer. All right, and if I run it, take a look. Here's the expected output of the program. I could type a number and then a simple math operator, this being a minus, a divide, a plus, or a multiply, and then another number, and my program should calculate what this is. So a few weeks ago, in the beginning of SI, we had a calculator program in which we wrote this program, we gave it 2 numbers, and it calculated every possible answer. It calculated the sum, the difference, the product, and the quotient. Instead, we want to do what I have up here, where it makes a decision based on the input and only calculates the thing that the user actually wanted. So let's take a look at doing that. So here is the blank program that I have for you guys, and you're going to help me fill this in. So you can type in chat or tell me out loud what you think that I should do. So I've included IOStream. I have using namespace standard. I have int main. I have return 0. I have the end of the main block. So all of that is there, but it is your job to help me out with actually making this happen. What do you think might be the first thing we need to do here? All right, someone says to add a double variable, and I think this is a great idea. So take a look at the example input. I did a 3 and a 2 and a star, 2 of which are doubles. So we need 2 numbers from the user. So let's make 2 double variables. So we'll say double, and I'll just call these A and B just because it's a calculator. It doesn't need to be very descriptive. We use A and B in math. This can work for now. All right, so we have double A and double B. All right, do you think we need any other variables by chance? Yeah, you're absolutely correct, Roger. We need one for the math operator. So the math operator is in the user input. In the previous program, I typed our math operator right here, and my program extracted that from the input, and it used it. So what type of variable do you think we might want to store a math operator in? So remember, this can be a plus, a minus, a divide, or a multiplication symbol. What data type is that? All right, let's do a string. That sounds great. So string, and I'll call it operator. Wait, nope, that was causing issues last night. I'll call this math operator. And this is why I test my programs before I talk to you guys about them. What happened last night, and it's a good thing to actually tell you guys about, but when I actually know what's happening, is notice how BBEdit is highlighting operator. In C++, operator is a reserved word. So it means something in C++. It does a thing. We don't know what that is yet, but it does something. Just like double. Double is doing something. It's declaring your variable to be of type double, a floating point. Operator does something. So this is a restricted word, meaning that we cannot use it for our variable names. So we had 3 restrictions on our variable names. Actually, how many were there? Several. I'm going to not count. We had it cannot be a reserved word. So here's a good example of that. So there's your reserved word example. It had to be made up of underscores, letters, and numbers, in which the number is not the first part of your variable name. So good thing to note. I just thought I'd let you know about that because that can come up. So math operator worked, but operator did not. All right, so let's just compile, make sure everything is still working, and it is. So we have a string variable for operator. So now we are asking the user, hey, enter a math expression. How am I going to take this as input and store it in the appropriate variables?
So you can have multiple variables on a CN statement, correct?
You are absolutely correct. You nailed it. Yes, that is exactly what we want to do here. So do you know how you would write that?
I was just guessing. No, I don't.
Okay, you're all good. So a little bit of background on the whole input sequence that happens in C++. It's probably a little bit more than you need to know, but it's worth knowing why this works. We can write cin, if I can type words, and then A, B, wait, no, operator. And then C, wait, B, oh my goodness. A, B, C. This is valid in C++. And it's, oh my goodness, that is not valid in C++. What happens when you don't sleep? You guys should all sleep. Okay, so this is all valid in C++. So we have a cin, and then we say A, operator, B. We could also have written the exact same statement equivalently as cin, B, and cin, these statements are 100% equivalent. They do the exact same thing. So just like with our cout statements, we could say cout hello, and then we could say world. And this would be the exact same thing as writing cout and then cout. Now those 2 statements, besides my capitalization errors, are equivalent. These 2 statements right here, this one and this one, are equivalent. We can split up a cout statement onto multiple lines if we'd like to. We can do the same thing with a cin. So we could take our cin statement, split it up on the multiple lines, or we can write it on one line. So either way works. It doesn't matter which one you use. So just use whichever one you are more comfortable with. So what is going to happen when this runs? So important thing to note about the cin stream, it stops taking input where? Who knows this fun fact? Very close. So a cin stream stops taking input at any white space. And white space is defined to be a space, a tab, or a new line character, which is the same thing as your enter or return key. So I think for the example, this one might make a little bit more sense. So let's take a look at this right here. And the user entered 8 star 7. And this was in the input. So what's going to happen here is cin is going to read for value A. Well, actually, this is stored on something called the input buffer. Don't worry about that, but that's the technical term for this, is the input buffer. So this is getting stored in the input buffer. So the cin stream says, okay, I'm going to take a number characters from here to store in A. It looks at the first one, it sees 8. It says, yes, that's great. So 8 gets put into the value A. Then it looks at the second one. It sees white space. It's like, oh, no. I cannot take white space. So it is done here. The cin got the A and the 8, and that was it. So 8 is now in your variable A. But all this stuff is still remaining in the input buffer, and that's where cin goes to look for input. So now it's going to look, what's the next thing? Oh, it's the math operator. That is a valid character. Nice. So it's going to take the math operator, store it in the variable, and then it's going to look again. Oh, wait, that's white space. I cannot have that. So it stops. So math operator gets filled in with the star. And this is now gone from the input buffer because we took it and put it in a variable. And lastly, cin's going to look in the input buffer again. It's going to say, okay, what's next? A 7? Cool. I know what that is. That is not white space. I can handle that. It takes it and it puts it in B. And then there's nothing left and it is finished with its job. That was a big explanation. You probably don't need to know that much technical stuff about it, but hopefully that explains why we can do this. So it's waiting for us to enter a math expression. We have 7 times 8. 7 goes in A, times goes in math operator, and 8 goes in B. Hopefully that's all okay. So we took input. I have the other version here just for you guys when it's on Canvas. Now we have A, which is holding our first number, math operator, which is holding our math operator, and B, which is holding 8. How are we going to actually make this print this? What's the next step? Yes. That is absolutely perfect. That is exactly what we want to do. We need to check what is happening with our math operator. We need to check, is it a plus? Is it a minus sign? Is it a slash? Is it a star? So we're going to use the if statement. And we have parentheses to enclose our expression, which can either be true or it's false. Nothing in between. So we're going to say our math operator. And then if it's equal to checks for equivalency. And then since we're using strings, you got it correct. We need to use a string here and we'll do a plus symbol. And then if so, we're going to do something. All right. So let's take a look at my comments here. We need to say, is it a plus? We did this. This one is done. Now we need to check, is it a minus symbol? So I could do one of two things here. I could do else if math is minus. And then I have my braces here. Or I could do if math operator is a minus. And it's up to you guys which one you want to do. In this particular problem, it makes no difference. I think the ifs are more straightforward, and just for that purpose, I'm going to show you guys the other one so you get more comfortable with it. So we're going to do else if our math operator is a minus. And then subsequently, here's the thing that I told you guys earlier, we can add as many else ifs as we'd like. So we're going to do another one. We're going to do else if our math operator is a, let's see, division symbol. and then we'll fill this up with code in a second. And then we could either say else, or we could do else if. So we saw this earlier. Else will catch everything else. Remember, if this is false, or this is false, we can kind of say, well, then it must be a star if they used our program correctly. If they didn't use our program correctly and imported something else in the middle here, then the else would catch a random thing and not be correct. So either way works. Just to show you guys the full sequence of things, let's do the else. So else have no conditions. So we're basically assuming it's a star at this point, because we gave them, they can only answer these 4 things. If it wasn't this, and wasn't this, it has to be a star. Okay, so now that I have these blocks, what do you guys think I should do with them? All right, I have a private message that says that we should actually use the else to catch if it is a incorrect operator. And I think this is a brilliant idea. So let's actually make another else if. And we can say math operator is a star. And then we'll reach this else if here. So what's going to happen when we reach the else if is when we reach the else, it's going to check, do we have a plus? Do we have a minus? Do we have a divide, or do we have a multiplication? And if none of these were true, remember we hit the catch all otherwise condition, this one's going to execute, which means that they entered an incorrect operator. So we can just let them know. So we'll put that in our else clause. So that's going to execute if they didn't enter one of the valid ones. What do you think we want to do in each of these little sections here? And once we do that, we are done with this program. So remember, the results of our program should output the math expression back to us and the answer. All right, I have a message in private chat that says that we should actually copy the message from private chat. And please, yes, there it is. All right, so it says that we're going to see out a plus b and then a string. So this is all going to output literally to the console. Then we're going to calculate what is a plus b, and then we are going to reach an end line. So let's go ahead and see what this looks like. So we're going to give me 1 second here. Is it this or is it something else? It is that. Okay, I think it is complaining about the type of quotes. So there's different types of quotes, and sometimes when you copy and paste stuff, it uses the wrong quotes, and that was causing an issue. So if you ever see something like this, just check that your quotes are correct. There's like, I think there's like curly quotes and there's not curly quotes or something like that, and it only accepts one type. So there is that. We're going to enter 6 plus 8, and it says a plus b is 14. Awesome. So we're going to do something very similar for the rest of these. We can just copy and paste, and then we can swap it out. So it says if we're a minus symbol, we're going to want to output the correct thing. And then we're going to make our change that we're going to do a minus b. And then if we're a divide, we'll say a divided by b, a divided by b, multiplication, a times b, a times b. And I'll save and run that. 3 times 2. And if I run it again, I could do a different expression. 8 divided by 5. I could do 9 plus 10. And I could do, here is our little feature that we added, 5 equals 10, or yeah, 10. Invalid operator. So that was a really good idea to actually make use of the flow of the if, else, and else commands, because we could say, if all of this else was false, we know it's invalid. So there's 2 benefits of this particular structure over one that would have said, if our operator is this, if our operator is this, if our operator is this, or if our operator is this. The first one is the one that we're seeing right now. We can have a catch-all statement at the bottom that says, okay, if none of these above worked, the user probably entered something bad. So this was a great example of that. Another reason why this might be useful is imagine you had maybe 100 of these statements and you're checking, is this, is this, is this, and you have a whole bunch of them. They're just going on and on and on forever, hundreds of lines. If they were all if statements, we would check every single one of them. We would check, is it a plus? Is it a minus? And even if it was a plus, it's still going to go down here and check, is it a minus? Is it a divide? Is it a multiply? Because the if statements are independent from each other. It doesn't matter that one of the previous ones was true, and that's like the only thing that we need to know. It's going to check every single one of them, so that can take extra time in your programs. And eventually, when you get higher up in programming, you'll be looking at how fast is my program running. And if you're looking for speed, something like this might be a better idea, because as soon as it saw that we're using a plus operator, it put this here. It said, oh, this statement is true. I'm going to output this. And it didn't even look at any of these other ones. It didn't exist. It just continued on with the rest of our program. So that's a reason why, 2 reasons why the else if combined with the if are useful. If anyone was wondering, well, why would I ever want to do that? It seems more complicated. All right, so that is the end of our calculator problem and everything that I'm planning on covering today. So feel free to stick around if you have any additional questions or anything else. And if not, thank you so much for joining. So sorry that we ran over. Hopefully it was worth it. And I will see you guys next time.